Fantasy sports platforms like Dream11 and My11Circ have revolutionized how fans engage with sports. What was once a passive viewing experience is now a real-time, strategic, and competitive digital game. Fantasy sports platforms like Dream11 and My11Circ have revolutionized how fans engage with sports. What was once a passive viewing experience is now a real-time, strategic, and competitive digital game. But have you ever wondered what powers these platforms behind the scenes? How does your team selection, live scoring, and final ranking happen in real time? Let's take a look at the end-to-end technology journey, powered by cloud computing and modern digital architecture. When a user opens the Dream11 or My11Circ app, the journey begins on the front end, built using responsive web technologies or mobile frameworks like React Native or Flutter. Users register, log in, browse upcoming matches, and create their fantasy teams. All user actions are sent to the backend via secure API calls through HTTPS. These platforms are hosted in cloud environments like AWS, Azure, or Google Cloud Platform to ensure scalability during high traffic periods, for example, just before a match starts. They also provide redundancy and availability, as well as performance optimization through global CDNs and edge caching. These platforms are hosted in cloud environments like AWS, Azure, or Google Cloud Platform to ensure scalability during high traffic periods, for instance, just before a match starts. They also provide redundancy and availability, along with performance optimization through global CDNs and edge caching. Each user interaction hits microservices responsible for specific functions such as authentication and authorization, team selection logic, match validation, payment, gateway integration, and notification services. These microservices run in containerized environments like Kubernetes clusters for dynamic scaling and isolation. Behind the scenes, data is stored in a combination of relational databases like PostgreSQL and MySQL for user profiles and match metadata. NoSQL databases such as MongoDB and DynamoDB are used for team combinations and session states. In-memory caches like Redis and Memcached handle real-time performance and leaderboards. User teams are saved, validated against the match rules, and stored securely. Once the real match begins, fantasy platforms integrate with live sports data providers like Sportradar, Cricsapi, or StatsPerform. These APIs deliver live ball-by-ball data such as runs scored, wickets taken, player substitutions, and match status, including delays and weather conditions. The fantasy engine consumes this real-time feed via webhooks or streaming APIs and starts scoring each user's team dynamically. This is where the heart of the platform kicks in, powered by a scoring engine. The scoring engine applies predefined rules like 10 points for a wicket, 1 point for every run, and bonuses for economy rate or strike rate. These rules are configurable in the rules engine, which applies logic dynamically based on match type, whether it's T20, ODI, or any other format. This engine computes and updates scores in real time, often using event-driven architecture with message queues like Kafka or RabbitMQ to handle high-volume score updates. As scores are computed, the leaderboard is refreshed in real time and pushed to all users using technologies like WebSockets or server-sent events or SSE for persistent connections. Pub submodels in cloud platforms are also used for broadcasting updates. This gives users a seamless experience as they watch their rankings rise or fall with every ball. Once the match ends and official stats are locked, a final scoring validation is performed. This includes final score verification, fair play checks like team edits after the cutoff, and cheating or bot detection via machine learning models. After validation, winners are declared and prize pools are computed based on contest rules. Winnings are credited to users' wallets or bank accounts, and notifications are sent via email, SMS, or push notifications. All data is logged and stored for auditing, dispute resolution, analytics for product and marketing, and player behavior insights. This is handled using data lakes like S3 or BigQuery and analytics tools such as Power BI, Tableau, or custom dashboards. Fantasy platforms handle sensitive data, including user PII and financial information, therefore security is critical. This includes data encryption at rest and in transit, tokenization for payments, role-based access controls, DDoS protection, and web application firewalls. Compliance with regulations like India's IT Act, GDPR, and others is also ensured. So while users are cheering for their picks, a complex cloud-native ecosystem is working tirelessly behind the scenes, processing millions of requests, updating scores in milliseconds, and making the entire experience seamless and secure. This is the power of cloud, real-time data streaming, scalable microservices, and AI/ML, making fantasy sports not just a game of skill, but a marvel of modern technology.